and is a manufacturer of high-end positioning systems and communication devices. My role is the responsibility of communication products Pacific Crest. And the Pacific Crest products are UHF communication products. And this particular discussion is about the use of UHF for high-end positioning systems called RTK. So that was easy. I've done the introduction already. So just a little information about Trimble. Trimble is a huge organization. It's listed on the NASDAQ and has a turnover of 2.3 billion annual sales. So we do value proposition. So we are offering a complete solution to the market in the space of positioning, communication, and related software to combine the three together. And Trimble is market leader in different core markets. So it's nice to have a look at the logo of Trimble. So that it consists of a triangle. Let's see where the pointer is. Oops, there was not the right one. Ah, here's the pointer. So it's a little triangle. So one points to the positioning part, one to high-end GPS, and the third one is software and other solution connecting the two together. Overview of offices around the world. So Trimble values the connected site, how we call this. So this is how we combine the three technologies together. Pacific Crest is a company designing and producing radio telemetry products, founded in the United States, with a track record of making products for the geomatics industry. And the geomatics industry is the industry that is involved in high precision measurements for survey industry and the construction and mining industry. So why is RTK important for India? RTK is an acronym for real-time kinematic. Real-time kinematic is turning a coarse GPS position into a 1 centimeter accurate position. And that is a highly advanced technology, which is not commonly used in India. In India, so far, a more previously used technology has been used, which is post-processing. So you take two measurements, and you start reading the positions from the GPS satellites, and then you bring the data back to the office, you do post-processing, and then you get the position. So real-time kinematic is basically an online way to do it in the field. So instantly, you've got the 1 centimeter accuracy. And that is what we are going to discuss here. So this little picture here is the person doing a survey, and we have the base station, and we have the system that is needed for the actual survey. So what this base station is doing, why is this needed? So we all know GPS, right? So GPS is a system that's basically an American system. We have GLONASS, that is Russian, Galileo, European, Compass, Chinese. So all of these constellations together, we don't call GPS, we call GNSS. So moving forward, I will call GNSS as the global constellations. So this is one of these satellites, and it can be any of the GPS, GLONASS, Galileo, and so on. So this satellite is transmitting its code on the carrier wave. So the GPS receiver is measuring the phase of the carrier, but it's also looking into the PRN code that is transmitted, that is broadcast by the GPS satellite. And by doing so, a very accurate time measurement can be carried out. So the time difference is known between the transmission, the start of the transmission of the signal and the receipt of the signal by the GPS. So the person here is doing exactly the same thing. He's also receiving the same signal from the same satellite, but he's in a slightly different position. So this part, this little white arrow here, this is one of the crucial parts for RTK, which I will explain a bit later. So here we have our friend again doing the survey, and what is RTK? That is basically doing an online measurement of the difference between two receivers, one on the base and one on the rover. So what exactly do we measure? That is ephemerid data. Ephemerid data basically is an accurate position of the satellite itself. So the satellite is moving around the world, but it's wobbling a little bit. So it's getting its information to correct its ephemerid from ground stations, and that information is sent through the carrier to the user. The satellite clock can be derived by receiving 4 satellites, because then we can have X, Y, Z, our complete position 3D plus the time, and the time is the clock error. And we measure ionospheric errors and tropospheric errors. So how come we can calculate the ionosphere and tropospheric errors? That is because we are measuring 2 frequencies. So forget about the standard car tracking systems or the very cheap GPS devices. They only use 1 frequency. We call L1. For RTK applications, we use 2 frequencies, L1 and L2, and sometimes L5 or another frequency. So we can derive the ionospheric errors that is in between the satellite and the rover, and the tropospheric errors. So all of these errors together we can calculate, and then we transmit these corrections to the user. So, and now comes the crucial part, because the receiver takes care of the calculation of the corrections. So these are expensive industrial type receivers, dual frequency as we call them. So when they receive corrections, they can handle the calculation of the 1 centimeter precise position. And what I would like to discuss with you is the use of a communication device to transmit the corrections from the base to the user. So these are the same errors that the base station has calculated, and these corrections are sent from the base to the rover and consist of the ephemerid, the clock errors of the satellite, ionosphere and troposphere corrections. So this is how a typical setup looks like. We have the base station here. So this is a land survey site where you can do the measurements. So this stays fixed. And this is my user segment. So this is my surveyor, and it has an internal radio, or you can use an external radio. So here is the receiver that is located at a precisely known position. So it has a known X, Y, Z, and it's calculating the corrections from that point, and it's then sending these corrections to the rover. So typically it's using its own language, that is the RTK language, It's called CMR, CMR Plus, RTCM. These are worldwide industrial protocols, and every high-end GPS receiver is using these protocols, either one of them. The radio link that sits in between, that is connecting the base to the rover, also uses its own language. So you see that it's ABC in, ABC out. It can be anything. So radios are transparent, but the radio packaging the information according to its own language. So some characteristics of UHF radios. UHF radios, the data radios, are in the market for a long, long time, but we see the technology evolving. We see Wi-Fi, Zigbee, all the nice new technologies. Why is using UHF still relevant? Because its signals are very robust, and but it has certain characteristics we must bear in mind, like a limited channel spacing, 12.5 kilohertz or 25 kilohertz, and a data throughput of 19K2 bits per second. So the range is important. Radios are line of sight, so you can get anywhere between 1 kilometer or maybe 80 kilometers, but if you are from one mountaintop to another, it might as well be 200 kilometers. The products that we have are high-end products. So this is just an example of a number of our products. These are finished products. They're very rugged in an aluminium housing and high power. And we also have OEM products for system integrators. The radios are fully programmable, so you can program the output power, but you also can program the channel spacing or certain frequencies that the radio come with. So just very briefly go over different products. So the Vantage is a 4-watt radio, and it has a display and a keypad, so you can easily program it in the field, or you can just check the configuration in the field. It has a very flexible design, serial input, so you can basically connect the radio to any sensor in the field, large input voltage. The Sentry is for other sorts of applications more robust. It doesn't have the display or the keypad. And this is the 35-watt radio. So 35 watt is a high power radio. It is allowed in India, but you will need to get a frequency license. That is an issue. So for system integrators, this product is very interesting. We work with many system integrators where this radio is used for many different applications, but a lot of our system integrators work in the field of combining navigation or positioning with telemetry. So this is the micro. It is basically just a small board, yeah, you can have a look at our booth at Advanced Technology to see how it looks like. So the radio can be connected via serial port, but it can also be connected to the internet. Internet connection makes it possible to both connect the radio directly to the application. So the application can be a sensor or the base station or a rover, and then remotely you can program the radio or measure the data or transmit data. And while you're doing that, so you can either have the direct connection between the radio and the sensor, but you can also break in and do the configuration. Another interesting application is monitoring. The radio is used in many monitoring sites like mining, open mine pits. In open mine pits, it is important to understand how stable the slope is. So they don't like accidents, and slope instability is a major threat. So they put measurement devices to measure the stability of the slope, and they use special software, monitoring software, to detect any changes of the position. And UHF radio are ideal to combine the sensor and the monitor PC, because in a mining operation or in a mining environment, the noise level is high. There's a lot of equipment. The range can be quite high. Also, there are metal constructions. So the high frequency devices typically are not as reliable as the UHF. So the radio comes with a number of interesting features. Auto roving, for example. So assume that you have a number of base stations installed. So you don't have to manually change the channel. If you are moving from one area to another, the radio follows the base station without interaction. Another way how you can set up a network is using smart repeating. Smart repeating, when you have a base station and you are working here out of range of the base station, you can use other stations as repeater. So you can either use a fixed repeater, or you can use a mobile repeater. So you can have it on a machine, for example, of a surveyor who is working there, or another device. So when one is switched off, for example, then this radio will automatically switch over to the second channel. So programming the radio is easy and can be done using either a configuration program or using an API command set. So all of our system integrators using the API commands to create their own application software as a shield around the products. And this is an example of what ADO config looks like, with interesting features like encryption, but you can also program addressing modes and other features that are in the radio. So I would like to give you a few examples where the radio is used. Well, this picture is taken from the Netherlands, my home country, and the Netherlands is very strong at dredging. So the entire dredging field of one of our largest customers in the Netherlands, they only use Pacific Crest radios for transmitting corrections, data, but also for sending information. So they want to measure the tide of the sea, and they want to collect all that information on the ship or on a monitor location that is on shore. So the marine hydrographic applications, that is where the radios are being used for a lot, and then mainly for positioning. But you see that it can be used for buoys, so remote buoys that are on a sea. So the range is not that great that you can have a buoy in the middle of the sea, but sometimes they're in the harbor, or they are just near shore. So these are other applications that are where UHF radios are important. Automated forklifts. These are used, for example, in the BMW factories and the Mercedes factories in Germany. They don't use positioning, not GPS positioning, but they are in the factory itself. So they transmit their data to other vehicles and to the central system. Snow guns, not very useful for India, I would say, but still. They must be switched off and switched on remotely and be monitored remotely. RTU control it's a great opportunity, and I think for India there is a good market. So RTUs are just the small programmable units that are used in industrial applications. So for all kinds of monitoring, the radio can be connected to the RTU. Same with wastewater management. Wastewater management, they monitor on a large area the quality of the water, and that is done by radios also. So this is an example how radios are used in networks. So these are GPS networks. So the GPS networks are installed, this is UK for example, and they transmit RTK corrections for the farming industry. So the farmers, they are using automated farming equipment to do auto steering, so they can steer hands-free. And that is important because they can save a tremendous amount on the seeds, and they can win time and the fertilizers, so they don't overlap when they are seeding and spraying the fertilizers, and that is a huge cost saver. This is also what we do. This is the container terminals, where these huge rubber tire gantry cranes are automatically steered also by GPS, and they use radios to receive corrections but also transmit the position back to the monitoring station. Some more examples. This is a dam stability system. So there is a robotic total station, which is an optical station that is just aiming to different points in the dam where you have reflectors. So because it's an optical system, it can measure to the millimeter what is the range and what is the position basically of that prism. So if there is any instability, even with a couple of millimeters, it can be measured. So because these are all remote sites, UHF is typically used to bring that information back to the office. The same with landslide stability and pipeline monitoring. Well, this is just extra information. So the temporary traffic lights or the public transformation information systems, they also use telemetry. They also use GSM. GSM can be quite expensive if you take the hardware and the subscriptions over a long term. This is one last example where you can use the rig move operation. So this is an oil rig. The oil rig has a position device, which is the base station, and he wants to know exactly what is my distance and position compared to the tugs. So he's not really interested in his absolute position, but during the move, he's interested in his relative position. So you can set the GPS device as a moving base system. So it's basically updating its own position all the time. So even when the whole system is moving, you can set this one up as a base station. So this is it might not be exactly antenna technology, but I thought it is very interesting because, like I said in my introduction, RTK is a growing technology. It's a high-end technology, and for India, I see that there is yeah, we're just about to see a huge growth in the country. So if you have any questions, I would love to answer them. And in any case, thank you very much for your attention.
Any queries, questions?
Any questions? UHF, communication, or we want to hit for the team? Okay, thank you very much.
Thank you very much for delivering the informative lecture. Thank you.
Thank you, Professor Sharma sir, for chairing this session, and I also thank all the presenters of this session. Now we will be having 15 minutes tea break, and after tea break we will be having research paper presentations as to session. Thank you.